So we're going to go straight to the lecture slide, and we're going to learn how rocks and minerals are being formed on the earth crust. Weathering, we talk about it. So this is where we learn about the paramaterial, the rocks. So as you know, this is the elemental composition of earth crust. Now surprisingly, earth crust, although it is a solid, it consists more majority of oxygen. And you know why? Because oxygen is actually paired with of other elements such as silicon uh, to form compounds. So most of the compounds of minerals that we see are actually the compounds from metals or non-metals that is paired with oxygen and whatnot, because the earth is filled with a lot of oxygen, up to 20 over percent. So you can see like most of the minerals that we have on the surface are consist of silicon with oxygen, aluminium with oxygen, and also iron. The rest of it are in smaller proportion, but with big difference as well, because most of these smaller proportion, starting from iron, magnesium, and going down, these are the nutrient minerals that is crucial for sustaining plant life on the earth's surface. Silicon and aluminium, they don't take part so much. They're actually the so-called that makes the structure or the physical face of the minerals. And once again, these are the total numbers, which I don't want to dwell too much. So I go straight about rocks. Now, so study of rocks is talking about petrology, or maybe if you have friends in other universities like UKM, they also have courses that learns about the rocks. And the name of it is called geology. And why geology is so important? Because that is where you get all the minerals, a precious one, or maybe the not so precious one like clay. But you know my idea. Rocks is actually another study. Most of them chemistry, but some is in physics. And most of the study of rocks involved in the what mining sector. Yeah. Okay, now rocks. There are several types of rocks that you need attention, and because of it, they also influence the level of weathering process, as we know, as we learned earlier just now. So there are three types of rocks. First one is igneous, that then the next one is sedimentary, and the third one is metamorphic. Now there is no order in these things because actually these three exist probably at the same time and they are in a cycle. So rocks can transform into one of these three like through specific process. So I think to explain this is better that I show you this diagram. So as you can see right here in this diagram, there are like three types of rock: igneous, metamorphic, and sedimentary rocks, in which there were like a transformation that happens between them, and they will like transform into one to another. But if you want to see where does it starts with here, magma. In fact, this is how it forms, how Earth formed. It forms from a very hot uh, planet. So when they say hot, that means hot enough that even though there are minerals, they're actually molten, they're melted. So Earth started with magma, and in fact, rocks also started with magma, in which this magma probably is in the nearer to the cores of the Earth, where the temperature can reaches up to like maybe thousands of degrees Celsius, and that is where most of these are melted. So when it comes to the surface, where it is cooler, it will turn into first igneous rock. Now, of course, igneous rock is still very near to magma. They can melt back into forming again magma, or if they are still pushing up and gets cooler, they become an igneous rock. Now, most of these igneous rocks, they are hard, they are very sturdy, and in terms of construction, these are the ones that usually civil engineers use lah, because they are like quite hard. Things like granite also is one. uh, Now, this igneous rock, when they are exposed to the element of the environment like water and also air, they might be weathered and eroded into smaller particles like sediments. So it could be sand, could be silt, and could be clay. And then for further interaction with the environment, so of course they will be deposited with water and whatnot. So when they have enough mass on top of each other, they will press. So when you have enough pressure, they also forms the second type of rock, which is sedimentary rock. So if you look carefully between igneous and sedimentary rocks, Sedimentary rocks actually is the small particle that were compressed back again. Now, in terms of strength, of course, it is not comparable to igneous. Because why? Sedimentary already broken up. And then you just, they were just formed back due to pressure and maybe a little bit of chemical interaction, compaction, and also cementation. Cementation is the reaction where they got stuck together due to a certain chemical reaction. It's just like cement. Now, cement, they are stuck together due to the presence or interaction with calcium. So when they form sediments, if there is calcium, they tend to cement, and when you compress it back, it will become a sedimentary rock. So again, sedimentary rock is not very strong. With weathering, they can be easily transformed back into sediment. Yeah. So this sedimentary rock, they have usually no strength, and usually they are not suitable for construction. However, this sedimentary rock is very important because they also have a lot of usage and application. Like chalk. Chalk also is another example of sedimentary rock. Previously, during my time, chalk are usually used for writing in whiteboard, not whiteboard, blackboard. Nowadays, you only know whiteboard, isn't it? But during my time, they were like blackboard, green color, and they use chalk to write. Yeah. Now, these sedimentary rocks is compressed because they are like in subsoil. They are in the deeper region of soil profile, and usually these kind of sedimentary rocks, they are formed in the riverbed. Yeah, because why? After all this erosion, they will transform. They will be carried away through rivers. After rivers into the open ocean. After ocean, then what? Ocean floor lah. So they settle, they sink to the ocean floor. But if you still remember in geography as well, we have now, of course, the Earth will have several different tectonic plates. Now, these tectonic plates is like the regions where you have a continent, and then they were going to clash with another tectonic plates from another continent. So what happened is these sediment, they are not static, even though they look static, but over a long period of time, these sediments, they will move due to the shifting of tectonic plates. So at one point, they are going to reach to the edge side by side with another tectonic plates, and they were going to rub down. So they're going to press down further into the earth. So not only they have pressure due to the pressure of tectonic plates, but they also like going deeper down. So the deeper you go into the earth, the more heat you're going to have. Because why? In the earth, you have core, the molten core, which is very hot. And with heat and pressure, they form metamorphic rock. So this kind of rock with pressure, with more pressure and heat, they will transform into rocks that are hard enough, maybe not as hard as igneous rock, but they're hard enough, and they look just like the sedimentary rock, but they're very hard. So they are probably formed in deeper regions of the earth, and due to movement of these tectonic plates, sometimes they go deeper down to form magma, or maybe they were pushed up into the hills that you can see. Okay, so some of these metamorphic rock, they were like a marble stone, batu mamar. Batu mamar is actually one type of metamorphic rock. They look very nice because of the sediments that they are formed, but they are hard enough to become a construction material due to the heat and pressure. So from metamorphic rock as well, it will be subjected as well for weathering and erosion and come back to sediments, or it can turn back to magma. So you can see this looks like a cycle. It starts with magma and it ends with sediment. But sediments also can come back to become metamorphic rock, and the cycle goes on. So these are the things that you should put in your mind. There will be question. Which rock is the question? Okay, that is the things that I cannot tell you. So you better know what is igneous rock, what is sedimentary rock, what is metamorphic rock, and the processes that forms them. So with that, I will going to skip all those examples. I won't going to tell you because I know you can read it yourself. I will not going to talk all these things. You can read it yourself lah. What are those rocks? Igneous rock, glassy texture. I don't want to cover. You read it yourself. Um, because I know if I read it, you're going to fall asleep. So these are just examples, which I want you to read yourself. And I will stop here for a while, just to explain to you what is metamorphic rock. So just now you know what is igneous rock. It comes from magma, cools down, then you get your igneous rock. They weathered down into sediments. So once they become sediments, they will turn probably into metamorphic rock with pressure and heat. So where does those pressure comes from? You see, there, according to this diagram, you can see there are like two tectonic plates. One that is on the left hand side, and one there on the right hand side. So if you look carefully on the left hand side, it seems like the sediment on the seafloor goes down. Now there are certain tectonic plates that actually will goes down just like this one, and then it's due to the shifting of tectonic plates. So this is where they have all the pressure, because we're talking about, I mean, it's immeasurable. I don't know what is the pressure there, but it's cool because you can see like they are like the whole the whole Earth plates clashing each other. So they are going down because of that. And then when they go deep enough, this is where you have the magma and they heat it. So with this pressure and heat, they form the what they call metamorphic rock. Yeah. So there are many types of metamorphic rock which I don't want to cover. You will read it yourself. And these are the examples of metamorphic rock that you probably have heard before. And some of them have become into some minerals that are very useful, very nice looking, such as this one right here, which I don't want to teach you this because essentially this slide comes from geology. So I won't going to go into the details of this one. You are going to learn this and read it yourself. I'm going to go through everything. Um, okay, so maybe a little bit right here because it looks so nice, kan? Okay. So you can see like minerals, they have so many types of minerals. I'm sure you've heard about sulfide, nitric oxide. So these are the salts or the anions. So when you combine with different cations, there you have different color. So most of this color of this mineral comes from the transition elements. If you look at alkaline earth elements, they don't give you so much color, either white or brown. Sometimes brown also comes from transition elements. Now, if you have some more interesting minerals like this one, now some of these minerals, they are used as gemstone because of their color. And why they have color? Because they have different cations inside. Now, for those who have learned general chemistry, you have learned transition element. Different transition elements give you different color. If you want blue color, okay, before that, red color first. Red gemstone comes from a certain mineral called manganese. But actually, there are more minerals that can give you red color as well. Cobalt. If you have cobalt, they also give you red color or maybe pink. So if you look at this azurite, azure means blue. Azure means blue. So where does the blue comes from? It can come from copper. It also comes from cobalt as well. So copper is a transition element and usually they give you blue. Sometimes copper also give you green color like malachite. Malachite also is a green color right here. Also contains copper. So you see, it depends on what kind of transition elements that you have and what is the oxidation state. So you can count actually the oxidation state of this copper, and this copper is different. That's why they give you different color. Okay, headlights have nothing, just fluoride, so they are white in color. And the rest of it, I leave it for your reference because I won't ask you question about this. After all, these are all geology questions which I don't think I want to explain to you further. And I'll come back to the summary of this slide and the lesson. So you might ask me which one is important. Do you remember where did I stop the longest and explain the most? Is this diagram. So enough said.